Okay, in this section we're going to be solving absolute value inequalities. So inequalities have the less than or equal to, greater than, or greater than equal to. So I'm going to start with working out a problem. We're going to sketch it kind of like the last lesson and then kind of see what's going on. All right, so 1A. So sketch f of x and g of x. And so let's do that first. And then, so f of x equals absolute value of x. And g of x equals 3. Let's go and start with that. And then I'll ask the question. Move this up. All right, so absolute value of x, well, that's doesn't go left or right, doesn't go up or down, so it's right there at the origin, 0. Okay, slope it, what's the slope? 1, so it's 1, so let me put a few lines there. Okay, actually, let's go back 3, up 3. Okay, so yes, up 1, over 1, up 1, over 1. Get it somewhat accurate here, up 1, over 1. Up 1, back 1, up 1, back 1, up 1, back 1. And draw your absolute value of x. Yes. Go. And then graph y equals 3. So 1, 2, 3. It's a horizontal line. Y equals 3. So this looks real similar to the last one we did. And let's go ahead and label this. The horizontal line, that was g of x. So that's g of x. So label it, because I want you to make sure we see which graph is which. This v is our f of x, so I'll put f of x right there. Okay, and then I'm going to write the way it's written on the homework so we can kind of see how it's being asked. So it says highlight the portion of g of x where f of x less than or equal to g of x. Just copy it, I'll explain. And state this interval. Okay, I'll go answer right there. All right, so let me finish copying that so I can show you what they're asking here. Okay, so it says highlight the portion of g of x. So we're kind of focusing on g of x. So actually put a little arrow pointing right to g of x. You'll kind of see why in a second. And then so we're focusing on g of x. I'm going to go over to g of x over here, and I'm going to put an arrow to g of x there. All right, so we're going to highlight, so we're going to shade the portion on g of x. So somewhere along g of x, this graph right there, I'm going to shade. So I'm going to look over here, and I'm just going to, from g of x's perspective, I'm going to read it like this, where g of x is, now how would I read this? Greater than, right? Opens up, the alligator opens up to the greater. So where g of x is greater than f of x. Okay, so greater than f of x. So I'm thinking, where is g of x above f of x? Where is it higher? Where is it higher? So let's go back to our graph, and let's see. For example, right here, here's g of x. Would you say g of x is below f of x? Yeah. Okay, so I'm not going to shade there. So where is g of x above or higher than f of x? Right here. So right here, g of x is bigger than it. Right here. So everywhere in there, it's there. So let's go ahead and shade like that. So it says highlight the portion of g of x where g of x is greater than. So I'd say right there. All right. So I would say, and then state this interval. I'd say from negative, I think this is -3, right? And all the way to 3. So from, I'm going to put square brackets. from -3 all the way to 3. That's where g of x is greater than or equal to f of x. Okay? I put a square bracket because greater or equal to. Okay, so when we solve this, we're actually going to solve where g of x is greater than f of x. When we solve this, this should be our answer. All right, so algebraically. So B, solve f of x less or equal to g of x, like this. Personally, I kind of don't like the way they do this. It sounds confusing, looks confusing, but I just kind of want to show you one time on a graph what it looks like. We're going to pretty much be focused on algebraically solving it, but I do want to show you this one time. Okay, so let's go ahead and solve this. So f of x, that's this one right there. So I'll put that right here. So it's absolute value of x. I'll put this symbol less than or equal to, and g of x, well, that's 3, so I'm going to put 3 right here. So we're going to solve this algebraically. All right. Well, there's not a whole lot to solve algebraically, but we need to set it up. We need to do a little setup. Just like on the last lesson, our setup was, oh, okay, well, this equals 3 or this equals -3, and that's our setup, and we solve. Well, same thing with this. All right, absolute value is less than or equal to 3, absolute value of x. So let me cover this up. What are some numbers that we can plug in? Because there's more than one. What are some numbers that we can put in there that makes this true? 2. There we go. 2. Absolute value of 2 is 2, and 2 is less than 3. Can we put 2.5 in there? Yeah. Yes. Can we put 0 in there? Yeah. Good. Can we put 4 in there? No. Okay. What about -1? Yes, we can, because absolute value -1 is 1, and 1's less than 3. Can we put -2? Can we put -3? Why? Yes, we can. Why? Equal to, yes. Negative. What about -4? No, we can't. Absolute value -4 is 4. 4 is not less than 3. Could we put -5? No. Could we put -6? No. Could we put 6? No. Okay, so now you're getting a picture of where all these are, aren't you? Okay, so it's, let me go here. So it's between what and what? -3 and 3. All those we can plug in there, right? We can't put -4. We can't put 4. We can't put 5. So it's in between these, all right? So this is our setup. So it's between -3 and 3. So -3 less than or equal to x less than or equal to 3. So all of these numbers, right? You said 2, right? 1, 0, 2.5, -2. These all work. Okay, and in fact, there's not a whole lot of work to do here. We're done. That's our answer. Any number between -3 and 3 makes this thing work. Well, look, isn't that what we just got up there on the graph? That's it. Okay, so and we'll write our answer as -3 to 3. We'll write it in interval notation. Okay. All right, so there's 2 types of setups in this. If it's less than, this is kind of how you set it up. If it's greater, there's another setup. Okay, so go ahead and write this. So put little quotes. This is a less than. Okay, less than. Sounds kind of funny, but write this. If I think, and this will help you memorize how to set this up. Less than, you think, kind of sounds like, but an and. Less than, and. Okay? And again, this might sound funny, but less than is an and look what we're doing. We're sandwiching it between the two, the negative and the positive. Okay, you may laugh, but write this down. Sandwich. Sandwich. Less than, you're thinking sandwich. That's your setup for a less than. You sandwich in between the negative and the positive. That's your setup. Believe me, we tend to forget how to set these up. Because if it's a greater, that's a different setup. All right. So if it says, from your variable's perspective, and you read it, this thing is less than, okay, sandwich it. Okay, and there's your answer. Okay. All right, let's look at one with a greater. That's a different setup. All right, so I'll squeeze it in here, number 2. So I'm not going to graph it, not going to do that. So let's say we have absolute value of x minus 3 is greater or equal to 2. Okay. Well, let's think of some numbers. Let me cover this up, and I'll show you the setup. So what are some numbers that we can plug in there under my pencil that will make this true? 2 will work, yes, because absolute value 2 is equal to 2. What else? 3 will work. Will 4 work? 4 is greater than 2. 5, 6, 7, 8. Will 1 work? No, because absolute value 1, 1's not bigger than 2. Will 0? No. Will negative 1 work? No. Will negative 2 work? Yes. What about negative 1.5? No, it's not big. Okay. So what about negative 3? Will negative 3 work? Are you guys following me here? Okay. Negative 3, absolute value negative 3 is 3. Is 3 bigger than 2? Yes. Okay, so think about all the numbers that we're saying. The numbers that are bigger than 2, or back here, like negative 4, negative 5, negative 10, negative 50, or less than negative 2. It's split, isn't it? Okay, so if you're thinking of the or, it's the ones that are bigger than 2 will work. Bigger or equal to 2. All those. Nothing in between. But less than negative 2 will work. Right? Negative 3, absolute value negative 3 is bigger than 2. Okay, so this one, it splits. It splits. Okay, so this x minus 3, this thing in there could be bigger or equal to 2, because you said like 3 works, 4 works, right? Or this x minus 3 can be what? What are some numbers negative that work? Like negative 3 works, negative 4 works, right? Absolute value negative 4, negative 5. It's back there. So this x minus 3 could be less than or equal to negative 2, right? You got the ones bigger than 2 or less than negative 2. It splits. It splits. Okay. So this is our setup. This is our setup. And then we just solve it algebraically and we get our answers. Okay, so well, how do we solve this? How do we get x by itself? Add 3. So add 3, add 3. So x is greater or equal to 5. Or, let's solve this one algebraically. So add 3, add 3. So x is less than or equal to 1. Okay, well, let's see. Let's write our answer in interval notation. All right, so I guess we'll do from left to right. So x is less than or equal to 1. Less than or equal to 1. So that's negative infinity all the way to 1. Square bracket. X is less than or equal to 1. Union with all these numbers. X is bigger or equal to 5. So how do we write that? 5 to infinity. 5 to infinity. So all these millions and trillions of answers will work. Okay, and it's just kind of split there. Right. So that's our answer. Okay, our setup is, you can go and write this. If this is read from the variable's perspective, it's greater. Think of this, just write greater. Greater. And then I think of greater as, again, it kind of sounds a little funny, but great or. So it's an or problem, and it splits. Okay? How does it split? This is our setup for a greater. The x minus 3 is greater than 2 or less than negative 2. Just think of it, picture it. It's bigger than 2 or it's less than negative 2. So it's this way, and that's how you set it up. Okay? So if it's a less than, you just sandwich in between, you get the middle. If it's an or, you split it, and that's your setup. Okay? If you remember the setup, then it's actually kind of easy to solve. It's just 1 through 14 on the worksheet. Okay. All right, let's look at another one. I see a few confused faces out there. Okay. Okay, number 3. Number 3. Absolute value, we're just going to do this algebraically. Okay, absolute value of 2x minus 5 is that. Is this a greater or a less than problem? Greater. So this is greater than 11. Okay, so if it's a greater, then we split it. Way out there, way back there. Okay, so here's our setup. This 2x minus 5 can be greater than 11. Just think greater than 11. Or what? Less than negative 11. So 2x minus 5 is less than negative 11. That's the setup to solve these types of absolute value problems. All right, so let's go ahead and solve it. So we add 5, we add 5. 2x is greater than 16. So divide by 2, so x is greater. By the way, when do we ever switch these signs, the directions? If you divide by a negative, or even multiply by negative. Okay, but we're just dividing by positive 2, so it's greater, this stays the same, greater than 8. Okay, let's go ahead and solve this one. So add 5, 2x less than negative 6, right? X is less than negative 3. These are your answers. But let's go ahead and write this in interval notation. So less than negative 3, I'll do that one first. So from negative infinity to negative 3, x is less than negative 3, union with from 8, and it's curved, right, because there's no equal there, union with x is bigger than 8, so 8 to infinity. Okay, so actually that's our answer in interval notation. Okay, they also want you to sketch the solutions. Okay, so on a number line. So that's easy. So let's go ahead and draft this. So I put negative 3 and 8. Okay. Okay, so it's less than negative 3. Okay, let's put an open circle. Right? Less than negative 3, I can shade it this way, or some of you guys learned how to do it this way. So, so it's less than negative 3. Or it's bigger than 8. So just bigger than, so open circle, and bigger than 8. So there we go. Okay, so your answer is usually split. Okay. So greater, you split it, that's your setup. And you solve it, you got your answer. All right? All right, let's look at a less than. So number 4. 2 absolute value, 5 minus 3x minus 1 is less than 13. All right, so let's isolate the absolute value. Let's get the absolute value by itself. So what do we do first? Add the 1. Okay, so add the 1, add the 1. So a lot of algebra here, but hopefully we're okay with it. So 2 times absolute 5 minus 3x is less than 14. All right. Then what? Divide by 2. So absolute value of 5 minus 3x less than 7. Got it? What's our setup? Is this a great or less than? Less than, so we do what? We sandwich it. What do we sandwich in between? So we sandwich in between the sandwich in between 7 and negative 7. 7 and negative 7. That's our setup. That's our setup. Okay? So we'll do this. Negative 7 this way, 5 minus 3x this way, and 7. So it's sandwiched between 7 and negative 7. That is our setup for a less than. Okay? That's our setup. Okay, now we got to solve this thing. Have you guys ever looked at it this way where you got 3 things there? Yeah. If not, no big deal. Whatever you do to one, quote, side, you do everywhere. So we want to get x by itself. Okay, so what do we get rid of first? The 5. Okay, so what do we do with the 5? Subtract 5. So subtract 5 there, subtract 5 there, subtract 5 there. Okay? That's what we have. So we have negative 12, this. What do we have left in here? Negative 3x, there we go, less than 2. Okay, so algebraically, let's get rid of the negative 3. How do we get rid of the negative 3? Divide by what? Negative 3, divide by what? Negative something? Divide by, so what do we have to do to the signs? Switch them, flip them. If you divide or multiply by negative, you change the direction of the signs. But let me put divide by negative 3, divide by negative 3, divide by negative 3. Okay? So this is positive 4, but instead of less than, that switches it. This is 1x, that's what we wanted by itself. This switches, we divide by it, so that switches, and that's negative 2/3. There we go. That's our answer. Read it from the variable's perspective. So x is bigger than negative 2/3, and at the same time it's less than 4. If you can picture that, it's bigger than negative 2/3 and less than 4. Okay, so it's negative 2/3 all the way to 4. That's our answer. That's our answer. And then if they want you to graph it on a number line, we can easily do that. Negative 2/3 and 4. So are these open circles or closed circles on the 2/3 and the 4? Open. How do I shade this? How do I shade it? It's between right there. Okay? Emily? Got that? Okay. Okay. Okay, so next one, we got to do a couple more. Sorry. Okay. Let's see. Number. All right. A couple more here, quickly. So number 5. Are we on 5? Okay. So absolute value, x plus 3. So I know this is getting late here, but these are just as important. Is greater than negative 2. We'll see these as well. We're going to actually want to see these types of problems. Okay, so absolute value. What do you think are? It's greater. Do we set up? How do we? What are your thoughts on this problem? No solution. No solution. What are your thoughts? Okay, no solution. Any other thoughts? Other than I don't like it. What other thoughts do we have on no solution? Any other? No other thoughts? Because there are some solutions. Good idea. I see what you're saying. They got a negative absolute value. Okay. All right. If you take the absolute value of a whatever number, is it always going to be positive? It is, right? And a positive number, I don't care what it is, a positive number, is it always going to be greater than a negative number? It will. It will. I don't care. This is a positive number. Greater than, it's true. This is always going to happen. So I'll even put always, always happens. So everything, I don't care what you plug in for x, it's a solution. It's going to work. So what's our answers? From negative infinity to infinity. Everything works. You give me an x number, a value for x, plug it in there, I can guarantee it works. Okay? Shane, give me a number for x. 2. What's 2 plus 3? What's the opposite of 5? It's 5. Is 5 bigger than negative 2? Yes. Joseph, give me a negative number, as big as you want. Negative 700 billion. Plus 3 is negative 600 billion, 996, negative. But take the absolute value of that, it's positive, right? It's bigger than negative 2. So there you go. All solutions. Okay. Good answer, Joseph. Okay, absolute value of x plus 3 is less than negative 2. We're going to want to see these as well. We just got to think about what the answer is. Is this ever going to happen? No. This positive number, whatever it is, 3, 7, 9, will it ever be less than negative 2? It's never going to happen. So just put never. So you put no solutions. Solutions. No solutions. Okay, and I got to do one last one. Okay, so you just have to recognize which is which. Okay? And just kind of think about it for a little bit and you'll know the answers. Okay, so last one. Negative 2/5 absolute value x plus 4 is less than or equal to negative 6. Okay, I just wanted to make sure we know how to deal with this fraction here. Okay, right now you might be thinking, this is a less than sandwich, right? But what do we have to do? We got to isolate this first. So what do we have to do to this negative 2/5? How do we get rid of this negative 2/5? Multiply it by. Multiply by what? The reciprocal. Or you could divide by negative 2/5 or multiply by negative 5 over 2. So let's get rid of it. Let's multiply by negative 5 over 2. And so whatever you do to one side, do to the other. So multiply by negative 5 over 2. Okay, so this is gone, this is gone. That's just 1, positive 1, right? So we have absolute value x plus 4. Instead of now less than, because we multiply by negative, instead of less than or equal to, it's greater or equal to positive what? 15. 15, 30 divided by 2, so 15. Okay, now we have it isolated. Now we can work the problem. This is a great OR. How do we set up an OR? We split it. We split it. Okay, so x plus 4 is greater or equal to 15, way out there, up there. Greater or equal to 15, or this x plus 4 is less than or equal to negative 15, back there, right? Less than or equal to negative 15. Just got to remember how to set those up. The split, great OR, it's an OR. So we said x is greater or equal to 11, or this x is less than or equal to negative 19. 19. Sorry, I didn't show the steps, but negative 4 minus 4. Okay, then interval notation, let's finish this thing off. So it's from, actually you guys tell me, how do we write this? Well, I'm doing this one first. Negative infinity all the way to, you're right, bracket on this one, but all the way to negative 19. So it's less than or equal to negative 19. Union with 11 to infinity. There we go, and I'll just, because you need to do this, negative 19, there's 11. So it's, do I put a closed circle or an open circle on a 19? There you go, closed, less than, but greater than 11. And there we go. Okay, so this section, less than, sandwich, great or, it's an or, but you split it. Okay, I'm going to shorten this a little bit because let's do numbers. I know it's probably different from your